So we've previously talked about linear functions and what they look like, and today we're going to start talking about exponential functions. And the main part about an exponential function is that things are not going by a constant rate. So whereas in linear functions we were going up by a constant rate of change, or going down by a constant rate of change by your constant slope. In an exponential function, or something that's being modeled by an exponential functions, things are changing by a different amount every single time, depending on how much of it we start with. Now today, we're just simply going to learn how to calculate the value of something after a certain period of time based on the information that is given to us, and it's pretty much going to be set up the same way for every single problem, just with different numbers. When it comes to exponential growth, to exponential functions, we can talk about exponential growth, meaning how something is growing, and we can talk about exponential decay, meaning how something is coming down or decreasing. But today we're solely going to focus on exponential growth, meaning how something is growing. So the equation that we use to calculate the final amount of something that is growing by a certain amount, by a certain percentage every single time, is this over here, what we have over here. So make sure you have this written down somewhere on your paper. And we use the same equation every single time. Okay, we have the equation y equals a, where a is your initial amount of something. So how much of something are you starting with? We always start with 100% of something, right? Whether something is going to go up or going to come down, we're always going to start with the whole. We're going to start with one whole of it, 100% of it. So that's why that 1 is always going to be a part of our equation, because we're always going to start with a whole of something, with 100% of something. R is the rate at which whatever it is that we're looking at is growing, and it's usually going to be given to us as a percent, and that percent is going to have to be changed into a decimal, and I'll show you how in a minute. And then T is just how much time has passed after that whatever it is that we're looking at has started to grow, in this case. And then next lesson you'll see what happens when things start to decrease instead. So in this example, it says the principal of a school predicts that the enrollment at her school will increase by 15% each year. So already I know that this is going to grow because it's increasing by 15% each year. That word increase tells me that it's going to be, this is something that is growing. This is a growth example. And it's increasing by 15% each year. If the current enrollment is 400 students, current enrollment means that right now the amount of students that we're starting with is 400 students. Okay, write an exponential growth function that represents the enrollment after X years. So X is the amount of time that has passed. So I'm checking to see, do I have the initial amount? How much did I begin with? Do I have the rate at which it's growing? How is the enrollment at the school growing every year? And how much time am I looking at? So I'm going to start to write down the information that is given to me. I know that I'm going to use the equation y equals a, which is the initial amount, parentheses, the whole that I'm starting with always, plus the rate and the time that has passed. So in this case, my initial amount, we started with 400 students. So I'm going to write that down. That's my A. The 1 stays the same. That's the whole that we always start with. My rate here, this is important. It's growing by 15% each year, but I do not want a percent here. Okay, when I'm substituting these numbers into my equation, I want to convert my percent into a decimal. So our rate is always your percent divided by 100. So in this case, my rate is 0.15. Make sure you double check in your calculator, because sometimes you might have some extra zeros, or you're missing some zeros because you think you're dividing it correctly. And then my time, how much time has passed, it tells me write an exponential growth function that represents the enrollment after X years. So do I know how many years have passed? No, right? They don't tell me how many years have passed, but they're telling me that we're going to use the variable x to represent that. So now I can go into my equation. I can go into this equation here, and I can substitute in the values that I've identified from the problem. So I have y equals a, which is the initial amount. What am I starting with? I'm starting with 400 students. Parentheses, the whole. I'm starting with the whole entire 400 students. Plus, since it's growing, I'm going to be adding to that whole. And it's growing by 0.15 every year. And I don't know how much time has passed. So instead of t, I'm going to put an x right here for time. And I can either keep it this way, or I can simplify it further to say that my equation would be 400 parentheses 1.15 to the x, and that's my function. Okay, remember, an exponential function is just an equation that looks like this. So now I'm going to use what I've just came up with in this problem in part A to answer part B. It says if the principal's predictions are true, meaning this equation is true because that's based on the principal's prediction, what would be the enrollment after 4 years? So now they're telling me the time, which means I can take these 4 years and I can substitute it into the equation that I have here. So I have y equals 400, again my initial amount, parentheses 1.15 to the x, and now in that x I can, since x is my time, and now I know how much time has passed, I can replace it with a 4. So I have y equals 400 parentheses 1.15 to the 4th power. And when I plug that into my calculator, not into y equals, I'm going to plug this into the regular calculator. I'm going to put this into the regular calculator. And when I put that into the regular calculator, it'll give me 699.625. But we're talking about people here. We're talking about how many people are going to be in this school after 4 years. And I can't have 0.6 of a person. And not only that, it's asking me to round to nearest whole number. So if I round this, it'll be approximately, these little squiggly lines mean approximately. It'll be approximately 700 students. And that's my final answer. So when you get to your task, all you have to do is identify the information that you need over here. So what's your initial amount? What's the rate? And remember to divide it by 100. And what's the time that has passed? Okay, sometimes they might ask you for the equation. Sometimes they might ask you to just go straight over here. They give you the time and you just plug in all the information.